We proceed. This is section P5 about simplifying algebraic expressions. Right. The distributive law says that a to the x plus b to the x is a plus b to the x. Actually, the distributive law is usually written like this backwards, from this left side to this right side. If you write it backwards from right side to left side, that's called combining like terms. So for example, 3 to the x plus 7 to the x minus 4 to the x, you remove a common factor of x, and that'll be times 3 plus 7 minus 4, which simplifies to 6x. That combines those terms. Here we have 3x plus 4x minus 7x minus 2x. These two are like terms because they have the same variable x. Minus 7x minus 2x, these are like terms because of the same variable y. Removing x from these two terms, you get 3 plus 4 times x. Moving y from these two terms gives you negative 7 plus negative 2 times y. And after a small amount of arithmetic, you get 7x minus 9y, which is simpler to write down than this, which is the point. Here we have an expression with 4 terms. 3x squared y plus 4x y squared plus 7x minus 7x squared y minus 2x y squared. Now these two terms, they have the same variable x and y, and they are to the same power, x squared y, x squared y. These two are like terms because they too have the same variables to the same power, xy squared, xy squared. These two, however, are not like terms because though they have the same variables, x and y, they do not have them to the same powers. Okay, these two, 3x squared y and minus 7x squared y, we can combine. So can these two. We get 3 minus y, 7 times x squared y, plus 4 minus 2 xy squared. And a small amount of arithmetic later, it gets 9 minus 4x squared y plus 2xy squared. Now, if you can add and subtract polynomials, you add them by adding like terms, and you subtract them by subtracting like terms. And remember, it's like terms of the same variables to the same powers. So for example, 3x cubed minus 4x squared plus 2x minus 1. All that plus 7x cubed plus 9x squared minus 10x minus 12. We add them by adding the x cubed powers, 3 plus the x cubed terms. 3 and 7 are called the coefficients. We add those coefficients, get 10x cubed. Minus 4x squared plus 9x squared, add the negative 4 and the 9 to get a plus 5x squared. Plus 2x minus 10x, add the coefficient and get minus 8x. And minus 1 plus minus 12 is minus 13. That's adding these two polynomials. To subtract the same two polynomials, we subtract like terms. 3x cubed minus 7x cubed. 3 minus 7 is a negative 4, so negative 4x cubed. Minus 4x squared minus another 9x squared. Minus 4 minus 9 is minus 13. So a minus 13x squared. Here we're getting into double negatives. 2x minus negative 10x. That's 2x plus 10x, or 12x. Negative 1 minus negative 12. That's negative 1 plus 12, or 11. Then there's the matter of multiplying polynomials. Here it's starting to get a little complicated. If you have a monomial, that's a polynomial with a single term, times another monomial, you get this, ax to the n times bx to the n. You multiply the coefficients, a times b. You add the powers, x to the n plus m. So for example, 2a squared plus 3a to the 5th is 2 times 3, a to the 2 plus 5, or 6a to the 7th. 1/6 g to the 4th, h to the 5th, times 36 g to the 7th, h to the 11th. Well, all right, coefficients are 1/6 and 36, 1/6 times 36. For g, the powers are 4 and 7, g to the 4 plus 7. For h, the powers are 5 and 11, h to the 5 plus 11. A bit of arithmetic, you get 6 g to the 11th, h to the 16th. Now we have 3 terms, and each one of them nasty. I'm making this as nasty as possible. Here we go. 2x squared y cubed z to the 5th times 4x, which is x to the 1st, y to the 5th z, which is z to the 1st, times negative 5x to the 6th, y to the 6th, equals. Okay. You multiply the coefficients. 2 times 4 times negative 5 here. Powers of x are 2 and, ooh, this is really an invisible 1, 2, and 1, and, well, here there's no x's at all, so we can ignore that. See, x to the second times x to the first. Y cubed, y to the fifth, y to the sixth, y cubed, y to the fifth, y to the sixth. Z to the fifth, z, which is z to the first, times z to the sixth. All right, here we go, we get out this whole thing. 2 times 4 times -5 times x squared times x to the first times x y cubed, y to the fifth, y to the sixth, times z to the fifth, z to the first, z to the sixth. Here we multiply these coefficients, get -40. Here we add the powers 2 plus 1 to get 3. Here you add the powers 3 plus 5 plus 6 is 14. And here you add the powers 5 plus 1 plus 6 is 12. So -40, x cubed, y to the 14th, z to the 12th. This business is about x actually being x to the first, something you have to be careful about, because I've seen people multiply, and because there's nothing up here, it just disappears, which is a quick way to lose a point. Now, have a single term times a polynomial. Well, I just use distribution. A times the sum is AB plus AC plus AD all the way up to AZ. So, well, okay, we'll get to that later. More generally, we have distribution A plus B times C plus D. You multiply by multiplying each term here times each term here. A times C plus A times D plus B times C plus B times D. We give it the name FOIL for first plus outer plus inner plus last. Now there's some special cases of products. Squares of a sum, square of a difference, sum times a difference. This thing, difference times square plus product plus sum plus square, excuse me. Here, sum times square minus product plus square. Cube of a sum, cube of a difference. Well, if you work it out using FOIL invariance, you get that the sum, the square of a sum is square plus twice a product plus a square. The square of a difference is square minus twice a product plus a square. A sum times a difference is a difference of squares. For example, if A is 10 and B is 1, then this is 11 times 9 equals 100 minus 1 is 99. That's why therefore I call this the 99 rule, and we'll be seeing it more later. Here you have a difference times product plus square plus, sorry, square plus product plus square, my apologies. And if you work it out and multiply and multiply and multiply each of these terms times each of these terms, then most of the term and all the terms in the middle vanish, and all we're left with is a cubed minus b cubed, a difference of cubes. Here we have a sum a plus b times square minus product plus square. If we multiply each of these times each of these, then everything cancels out, except for a cubed plus b cubed. So this is a sum of cubes. Now, please do not confuse a sum of cubes with a cube of a sum. Very different. Math has lots of what amount to grammatical quibbles like that, and you have to watch out for it. Okay, if you work it out, it's basically if you multiply, say this, a squared plus 2ab plus b squared times another a plus b, and the terms all add up and so on, you get this cube plus 3a squared b plus 3ab squared plus b cubed. You have a cube of a difference, which is a lot like this one, only it alternates the minus signs. Plus a cubed minus 3ab a squared b plus 3ab squared minus b cubed. These are special cases of polynomials. And all these you can derive from general long multiplication of polynomial times polynomial, which is basically the same as long multiplication that you learn in elementary school, only there's no need for carry. So for example, 2y cubed plus 3y plus 2 times 3y plus 2. First we multiply 2 times all of these terms. 2 times 2y squared is 4y squared, 2 times 3y is 6y, 2 times 2 is 4. Then we multiply 3y by all of these terms. 3y times 2y squared is 6y cubed. And you'll notice and 3y times 3y is a 9y squared, and 3y times 2 is 6y. You notice that I put these three terms, I offset it by a bit so that the y squareds and the x and the y's line up. Then you add them, and here you go. 6y cubed plus 4 and 9 is 13, 13y squared plus 6 and 6 is 12, 12y plus 4. Now here we have, I'm going to prove this one here. Here we have square plus product plus square times a difference. Let's see what happens. Okay. Negative y times x squared is negative xy squared y. Negative y times xy is negative xy squared. Negative y times y squared is negative y cubed. X times x squared is x cubed. X times xy is x squared y. X times y squared is xy squared. And again, these three terms, I move over one to the left so the like terms line up. And when you line them up, whoop, these cancel and these cancel, and all we're left with is x cubed minus y cubed. And that's how you prove this rule. And you can prove this rule pretty much the same way, ditto this, and so on. So for example, here we have a difference of polynomials. 2x squared minus 5x minus the quantity x squared minus 8x plus 3. Okay, first thing to do is distribute the negative sign over these three terms. So 2x cubed minus 5x minus an x squared minus a negative, which is plus an 8x minus a 3. Okay, then you combine like terms. 2x squared minus x squared is x squared. Minus 5x plus 8x is 3x. And minus 3 is minus 3, so this is the result. X squared plus 3x minus 3. 3 times x minus 1 plus 4 times x plus 2. Okay, first we'll distribute the 3 here and distribute the 4 here. So you get 3x minus 3, 4x plus 8. Then combine like terms. 3x plus 4x is 7x, minus 3 plus 8 is 5. In a sense, what we did here was first use the distributive law twice, then reverse the distributive law also twice. We have x cubed plus 6x squared minus 4x plus 7 minus a 3x squared plus 2x minus 4. Well, okay, again, we'll distribute the negative sign over these three terms. Get x cubed plus 6x squared minus 4x plus 7 minus a 3 minus a 2x minus a negative 4 is plus a 4. Then combine like terms. There's only this x cubed, so there it goes. 6x squared minus 3x squared is a 3x squared. Minus 4x minus 2x is minus a 6x. 7 plus 4 is 11. Here we have two terms times two terms. 3x plus 5 times 2x minus 1. This is a job for FOIL. First terms is 3x times 2x. Outer terms is 3x times minus 1. Inner terms is 5 times 2x. Last is 5 times negative 1. So these come out to 6x squared. These come out to minus 3x. These come out to 10x. This comes out to minus 5. And these are the only like terms needing combining, which minus 3x plus 10x makes a 7x. So you get 6x squared plus 7x minus 5. There's the answer. We have a square of 3x minus 1. Now here we'll use the square minus twice product plus square rule. Square of 3x minus twice 3x times 1 plus 1 squared. And after a bit of algebra, it's 9x squared minus 6y plus 9y squared minus 6y plus 1. Here we have x plus 2 times x squared plus 2x plus 3. This is a job for long multiplication. Here's x squared plus 2x plus 3. Here's x plus 2. Let's do multiplying. 2 times x squared, 2x squared. 2 times 2x, 4x. 2 times 3, 6. Now, x times x squared is x cubed. X times 2x is 2x squared. X times 3 is 3x. And again, these three terms I offset by 1 so that like terms will line up. Simplifying calculation. And you get x cubed plus 4x plus 7x plus 6. Okay.